Hey guys, I'm not going to shout over you, please. What is the graph? So, I can wait. I have more time than you. Okay, what is the graph of y equals x squared plus 2x plus 3 going to look like? So this is now standard form. Standard form is y equals ax squared plus bx plus c. So what is A, B, and C if that is standard form? Well, A is 1, B is 2, and C is 3. A is 1, B is 2, and C is 3. The axis of symmetry is a little unique in standard form. It's negative b divided by 2 over a. So the axis of symmetry now comes from the idea that it's negative 2 divided by 2 times 1. So negative 2 divided by 2 is negative 1. Negative 2 divided by 2 is negative 1. So what that means in terms of my graph is that about the line x equals negative 1, we're going to have all our points of symmetry. The y-coordinate of the vertex comes from plugging the axis of symmetry, or our h, this represents h from last week, in to the function. So I need to find the y-coordinate, or the k value, by plugging negative 1 in to x squared, in to x, and simplifying. So you get negative 1 squared, which is 1. Then you get 2 times negative 1, which is negative 2, plus 3. So 3 plus 1 is 4. 4 minus 2 is 2. So that represents k. So my vertex is negative 1, positive 2. Once you have your vertex, graphing a quadratic is super easy. This is why we graph from vertex form before standard form, because standard form takes a little bit more effort. You can't just simply look at the graph and look at the equation and know what to do. You have to apply some of those points. So it's negative 1, positive 2. And then you create your table just like we've been creating our table. So we're going to create our table the same way we've been creating our table. We're going to do x plus h, ya plus k. So it's 0, 1, 2. In this case, h is negative 1. And then 0, 1, 4. A is 1. A is the same for standard and vertex. And k is positive 2. So we get 2. So negative 1, 2, which we have already plotted. 1 times 1 is 1. 1 plus 2 is 3. So we're going to plot the point 0, 3. And then 4 times 1 is 4. 4 plus 2 is 6. So we're going to go back to my graph and plot those key points. So you have negative 1, 2. We're going to plot 0, 3, and 1, 6. And if it goes up 1 and right 1, it goes up 1 and left 1. If it goes up 4 and right 2, it goes up 4 and left 2. So here is my perfectly symmetric curve. So y equals x squared plus 2x plus 3 looks like this graph over here. And in vertex form, it would be y equals 1, x minus h, so plus 1 squared plus 2. So this is the vertex form. The y-intercept, if you look over at our graph, it's at 3. The y-intercept is always the c value in standard form. So in this case, the y-intercept is 0, 3. So the y-intercept is always the c value, or in this case, 0, 3. When converting standard to vertex form, we're pretty much going to do the same steps we just did previously. So when converting from standard to vertex, we're pretty much going to do the same thing we just did. You're going to identify A and B. So A is 2 and B is 10. We find the H value by applying the formula negative b divided by 2a. So the reason you find b and a is to plug into your formula. So it would be negative 10 divided by 2 times 2, which is negative 10 over 4. You multiply the bottom numbers together before you divide. So this is really like negative 5 over 2. Or negative 2.5. I personally will stick to fractions, but I know there are some of you that like your decimals. The y-coordinate of the vertex, or my k value, comes from plugging my h value in. So that's 2, negative 5 over 2 squared, plus 10, negative 5 over 2, plus 7. So order of operations says you square before you multiply. So you get 2, and then anything negative squared is positive, so you get 25 over 4. 2 and 4 simplify to 2. And then 10 times negative 5 is negative 50. Negative 50 divided by 2 is 25. So we have 25 plus 25. And then plus 7. So again, when you do these, you want to make sure that you are multiplying. Somebody say something? So this one, it's 25 divided by 2. Because like I canceled the 2 and the 4. So it'd be 12.5 or 25 over 2. Because here's your 25 over 2. Because here's your 2, and then that would become a 4. So it was 2 and then 25 over 4. But 25 stayed and 2 over 4 became a 2 in the bottom. Because 2/4 is the same as 1/2. Yep. What? Yes. So that gave you 12.5 minus 25 plus 7. So that's negative 5.5 or negative 11/2. So vertex form is A stays the same, so it's 2 x minus h, which is negative 2.5, or negative 5/2. So again, either or is fine. Don't forget your squared plus k, which is negative 11/2. And if you want, you can simplify the minus and minus to positive. But that is your equation in vertex form. Okay? On the back, we're going to look at a word problem because I know how much you guys love word problems. So we can also interpret a quadratic function. So we have the New River Gorge Bridge in West Virginia. This is actually the largest steel arch bridge in the world. So, and I'm sure many of you have actually driven over it, you just don't realize it. It can be modeled using that equation given to you. How high above the water is the arch, and how long is the section of the arch? So, if you look at the diagram, the height above the water is going to occur at the highest arch of the bridge, which is right here. This bridge essentially mimics a quadratic function. So here's your quadratic function. It's open down like a frown, hence the negative on the A value. So what do we call the highest point or the lowest point of a quadratic? Yeah, the max or the min. The max or the min occurs at the vertex, which is represented by h comma k. So if I want to know the highest point of the arch, I want to find the vertex. This equation here is in standard form. Interesting. So what we're going to do is take that equation and we're going to find h and k just like we've been doing. So the h value is negative b divided by 2a. So you're going to fill in your negative b, fill in your 2, fill in your a, and get your approximate value. Now this would be a calculator style question because look at those decimals. So I already have the work up. What I'd like you to do is use your calculator and try to match those values. Okay? Everybody okay with typing those in on their calculators and getting those values? Do we understand how and why they represent what they represent? So that 850, if you go back to the archway, that 850 represents half the length of the bridge. That 850 represents only half the length of the bridge. Because it's the distance from the beginning to the middle. So the entire length of the bridge would then be what? How do you find the entire length of the bridge? What? Yeah, because what did you do? Yeah, so to find the entire length of the bridge, you would have to take that 850 and essentially double it to say that the entire length of the bridge is 1,700 feet. So it says, how long is the section of the bridge above the arch? The section of the bridge above the arch is 1,700 feet. So I know you guys turned in homework to me today. I'm going to take today to check that. So you're supposed to have uploaded those 2 pages from the end of the packet from Thursday and Friday. I'm going to check those tomorrow. We'll go over the answer keys to all of that. And then we will look at properties of parabolas even further. So for today and your remaining time, because I know this is a lot, I know that graphing in standard form involves a lot of work and effort. So what I'm going to do is kind of give you a little cheat sheet. Your homework is obviously that homework day 3. So it asks you to find the Y-intercept. The Y-intercept, so if you have y equals ax squared plus bx plus c, the Y-intercept is always 0c. And again, remember that pink table I gave you the other day? All of this is on that pink table. And I said, hey, take a picture of my board. I also posted it on our team's channel. But this is the key info for standard form. Y-intercept is always 0c, where the c value is coming from your equation. The AOS is the equivalent of x equals h, which is negative b divided by 2a. You have to find k by plugging into the equation. Your vertex is still and always will be h comma k. But again, you have to find h and k, where h is negative b divided by 2a, and k is found by plugging h into the equation. So it's kind of like y equals a h squared plus b h plus c. And then the last thing you have to do to graph it is to make your table. And again, it's x plus h, y a plus k for 0, 1, and 2, 0, 1, and 4, never change. And then you plot your points and get your graph. So you have 8 graphs, I believe, to do for homework, using that method and putting pretty much all of that key information on there. So again, hence the amount of time I'm giving you to work on this. I want us working quietly and independently. If we start talking or getting loud, I'll either A, move our seats, or B, shut us down and make us do the problems as a class. Yes. So looking at that first one together as a group, let me switch to my document camera for you. There we go. So I always just like to say, okay, what's A, what's B, and what's C? So this one's a little tricky because there isn't, my B value is 0. So A is 1, B is 0, and C is 3. So my Y-intercept is 0, C. So C is 3. So my Y-intercept is 0, 3. That also tells me on my graph, I'm guaranteed the point 0, 3. That point's not my vertex, though. It's just a point I'm guaranteed on my graph. Then I need to find H and K. So H is negative B, which is 0, divided by 2A. Well, anything with 0 in division is 0. Plugging 0 back in is how you find K. So K would be equal to 0 squared plus 3, which is 3. And ironically, my vertex is 0, 3. So I told you that wasn't your vertex, it actually was. But that's not like guaranteed, that just happened to be this example. So then I like to make my table. So in this case, my H value is 0. So I'm going to take that 0, 1, and 2 and add 0 to them. So my X's stay 0, 1, 2. My A value is 1 and my K value is 3. So my Y values would be 0, 1, 4 times 1 plus 3. So I get 3, 4, and 7. So I plot the point 0, 3, which is on my graph, 1, 4, and 2, 7. And again, I know if the point goes up 1 and right 1 from my vertex, it goes up 1 and left 1 from my vertex, up 4 and right 2, goes up 4 and left 2, all from the vertex. So there's my quadratic. It's shifted up 3 units. Domain is all reals. Arrows are important. That implies this continues forever. And the range is y greater than or equal to 3. This is a min. And again, I know it doesn't ask you for all that, but that's just things that we will be talking about and moving towards as we continue these problems. Okay?